Have you ever wondered what lies beyond the edge of reality? Imagine a place in the universe where time stops, light disappears, and the laws of physics seem to crumble. That place is a black hole, born from the death of massive stars. Black holes are cosmic abysses with gravitational pulls so strong that not even light can escape. Their existence was once just a theory, whispered among physicists. But today, we've captured their shadows. Dark silhouettes etched against the glowing fabric of space. At the heart of a black hole lies the singularity, a point of infinite density. Matter is crushed, space is warped, and time is no longer linear. But here's the twist. Some scientists believe that black holes may not be the end. They could be gateways. To what, you ask? Enter the concept of white holes, the mirror opposite of black holes. Instead of pulling everything in, they explosively push matter out. Nothing can enter a white hole, just as nothing can escape a black one. Are black holes the entrances and white holes the exits? Could they be part of a cosmic tunnel, a wormhole that connects distant regions of space or even other universes? We don't have all the answers, but in this series, we'll dive deeper into the mysterious mechanics of black holes, the wild theories behind white holes, and the mind-bending possibilities of interstellar gateways. So, if you're ready to fall into the unknown, don't forget to like this video, subscribe to Deep Space Docs, and hit the bell to never miss a journey beyond the stars. Have you ever wondered what happens after crossing the event horizon? Time and space twist in unimaginable ways. To an outside observer, it appears you'd freeze right at the edge, suspended in time forever. But from your perspective, you fall through in mere seconds. Inside, the rules of physics begin to unravel. Matter is crushed to infinite density. This singularity is a point of no return, a region where even the laws of cause and effect may no longer apply. And yet, there's something more chilling than falling into a black hole. What lies on the other side? That's where the concept of a white hole comes in, a theoretical counterpart that reverses everything we know. Instead of swallowing matter, it spits it out, constantly, violently. Nothing can enter, only escape. But do white holes actually exist? Or are they just elegant equations with no place in the cosmos? Before we dive deeper, make sure to subscribe to the channel and like the video so you won't miss what's coming next in this cosmic mystery. Imagine, for a moment, that a black hole and a white hole are two mouths of a tunnel through space and time. A wormhole. This is not science fiction. It's a serious idea proposed by Einstein and Rosen in 1935, what we now call the Einstein-Rosen bridge. In theory, a wormhole could connect distant parts of the universe, or even different universes entirely. Enter through a black hole, exit through a white hole, light years or realities away. But there's a catch. Wormholes are unstable, incredibly so. They collapse faster than anything can pass through, unless, of course, we could hold them open with exotic matter, a substance with negative energy. No such material has ever been observed. But if it exists, wormholes could be the ultimate cosmic shortcut, a way to bypass space, time, and perhaps even death. Just imagine civilizations older than stars, traveling through these hidden tunnels in the dark fabric of the cosmos. Crazy? Maybe. But in the vast silence of the universe, who's to say what's impossible? Subscribe now and hit the like button if you're as fascinated as we are. The next chapter gets even stranger. Here's the riddle that keeps physicists up at night. What happens to information when it falls into a black hole? Imagine throwing a book full of data into a black hole. According to Einstein's theory, that book is gone forever. But quantum mechanics disagrees. It says, information can never be truly destroyed. This conflict between Einstein's general relativity and quantum theory is known as the black hole information paradox. For decades, no one had a clear answer. Then came Stephen Hawking. He proposed that black holes aren't entirely black. They emit a faint glow, now called Hawking radiation, particles slowly leaking out over billions of years, causing the black hole to evaporate. But this radiation appears completely random. No sign of the original information. If that's true, then physics, as we know it, breaks. Yet some believe that information is encoded in the radiation, just in an unimaginably scrambled form. Others think that black holes leave behind a remnant, a kind of cosmic hard drive, and then There are those who believe information escapes not into our universe, but into another. A white hole, perhaps. One mystery leads to another. Hit that like button if your mind's spinning too. Subscribe to follow the trail deeper into the unknown. Now let's flip the cosmic coin. If a black hole is a region where nothing escapes, then a white hole is a region where nothing enters. It spits out matter and energy, but won't let anything in. Sounds unreal? Well, mathematically, white holes are allowed solutions to Einstein's equations. They're like black holes running backward in time. Some physicists believe that white holes could be the final stage of black holes. When they've evaporated completely through Hawking radiation, they might explode in a burst of information, reborn as white holes. Others suggest something even wilder. What if every black hole connects to a white hole in another universe? A tunnel through space and time. A wormhole, not just sci-fi, but a serious concept in modern theoretical physics. And here's the twist. If white holes exist, they may explain where all the lost information went. Not destroyed, but transferred. A cosmic balance between creation and collapse, between light and shadow. The universe may be far stranger and far more elegant than we ever imagined. Like this video if the cosmos just blew your mind. Subscribe to Deep Space Docs, because this is just the beginning of the mystery. Imagine it. In one corner of the universe, a black hole devouring everything in its path. In the opposite corner, a white hole spewing matter and energy, refusing to let anything in. Now, picture them on a collision course. What happens when the universe's ultimate destroyer meets its ultimate deflector? This is not just fantasy. It's a serious theoretical question. If a black hole and a white hole were to meet, the result could be explosive. The black hole would try to absorb the white hole. The white hole would resist, pushing everything away. A cosmic tug of war, gravity versus anti-gravity. Some physicists theorize that such an encounter might cancel out both objects, resulting in a massive burst of energy, maybe even creating a new kind of particle, or a gateway to another universe. Others suggest the clash could form a stable wormhole, a tunnel through space-time linking two distant points, or dimensions. We don't know for sure, because white holes remain a mystery. They've never been observed. Maybe they don't even exist. But if they do, the universe is hiding a secret war between light and shadow, a battle we've never seen, but one that might have shaped reality itself. Subscribe to Deep Space Docs if your mind just bent a little, because space isn't empty. It's full of impossible possibilities.